Hey, welcome back. So this video is continuing with inheritance, but we're going to talk about a special case called multiple inheritance. But before I even introduce it or explain what it is or how it works, I just want to set things up by saying this is a topic that really I could have left out of the course. I did some research ahead of time to see if anyone covered it, and out of all the big existing Python courses, nobody mentioned it. That doesn't mean that I shouldn't cover it or that it's not worth learning, but it does show us that it's not that commonly used and it's not viewed as super important. But the reason I decided to teach it is, one, to be thorough, but also I think it helps illuminate certain things that are happening behind the scenes with inheritance. So the point of this video is not to show you something that you'll be using all the time, but in showing to you how multiple inheritance works and some of the things that arise when we implement it, it will help you understand how Python works underneath the, behind the scenes, under the magic, how inheritance is implemented. And that's all I'll say about it for now. So with all of that said, let's talk about it. Multiple inheritance. So it's kind of what it sounds like. We've seen how to have, one class inherit from another parent class, a single parent class. And all we would do is pass something in here like, person class. That wouldn't really make sense here, but the aquatic class now inherits from person. Well, I have an example here now where I have two different classes. This is a super trivial example modeling animals. So we have aquatic, which each instance just has a name, like Jaws or Sharky or Fishy. It has a swim method that returns the name Jaws is swimming or Fishy is swimming. And then a greet method that returns I am self.name of the sea. Then there's a second class called ambulatory. Ambulatory just means walking, so kind of the opposite of an aquatic animal, although I don't think it actually is the exact opposite, but in our case, just another type of animal. And ambulatory instances have a name also. They have a method called walk, which just returns, self.name is walking, Lassie is walking. And then they also have a greet method, I am Lassie of the land instead of the sea. Okay, so these two classes have nothing to do with one another. They look kind of similar, but they're not connected. No inheritance. Then there's a third class down here called penguin, and penguin inherits from both of them. In this case, we pass in two classes to inherit from. So every instance of penguin, which it's ambulatory, it's a walking animal, but it's also aquatic. So it kind of makes sense in this example. But every penguin has all of these methods from aquatic and all of the methods from ambulatory. And if we look at the init in penguin, it's really, really simple. It just calls super.init. In a moment, we'll explore what super is actually referring to. But before you even get there, let's just take a look. Down here, I have three examples where we have Jaws is equal to an aquatic instance, Lassie is an ambulatory instance, and then Captain Cook is a penguin instance. And we can do things like, obvious things like Jaws.swim or Lassie.walk. But let's play with Captain Cook. Let's do print Captain Cook.swim. And if we run it, we get Captain Cook is swimming. All right, so that's coming from the aquatic class. If I do the same thing, but this time I do walk, that will be coming from the ambulatory class. And I get Captain Cook is walking. All right, so that's coming from ambulatory. So we have proof now that penguin is getting methods from both parent classes. Now the question is, when I call .greet on Captain Cook, which greet is going to be called? Any guesses? We have two. They're both named greet, and they do kind of the same thing, except one says of the sea and the other says of the land. Okay, let's see what happens. And we get, I am Captain Cook of the land. So it's calling the version from ambulatory, not from aquatic. And we'll talk about why in just a moment. There's one other thing I want to point out here. I've already typed this up ahead of time, where I'm just using instance of 3 different times with Captain Cook to see is instance returns true or false. If Captain Cook is a penguin, it should be true. If it's aquatic, true. Ambulatory, true. So we should see 3 trues, and that's indeed what we get. So this shows you that in Python's mind, Captain Cook is an instance of Penguin, but it's also an instance of Aquatic and Ambulatory. And on top of that, it's an instance of base object, which we didn't have to test out here, but we saw that earlier. All right, so now let's explore a bit about the order that things are happening in. And the next video is actually going to go into a lot more detail on that. But for now, let's just comment everything else out here and only focus on Captain Cook. When I call Captain Cook or Penguin Captain Cook, this is run, right, init here, and it calls super.init. So let's kind of trace the path that things are happening in. So I'm going to do a print Penguin init, and then up here I'm going to move into the ambulatory init and type ambulatory init. Got to make that all caps. There we go. And one more time for aquatic. I'll do aquatic init. So what do we expect to see? When I call super here, which version or versions of init are actually going to run? Let's see. So we only get Penguin init. That makes sense. That's where we started. We made a new Penguin. And then ambulatory init. So aquatic was never called. And that order, again, is something we'll talk about in the next video and how it's established. But the super simple version is that ambulatory is first. If we move it after aquatic, we now get Penguin init, then aquatic init. Okay? So again, we'll come back to that in the next video. But one thing I want to be super upfront about and make very clear, we still have access to these methods in ambulatory and aquatic, even if init never occurs or it's never run in that particular class because of this inheritance right here. Okay, so I'm going to change it back. So putting the order that things are running aside, let's say that we wanted both inits to execute, both in aquatic and in ambulatory. I don't know if you can hear that siren, but there's an ambulance outside right when I'm saying ambulatory. Okay, let me edit this out. Okay, I'm back. So if we want to have both inits run, we can actually just manually call them. So if ambulatory is running, we can also just call aquatic dot double underscore init. But remember, if we're not using super, we have to pass in self. And then we could do name equals name. Now I should point out this is kind of a bad example at this point because name is defined in both places, aquatic and ambulatory, and you probably wouldn't want to do that if you had multiple inheritance have the same property defined in more than one place. So for this example, we could change name, but I'm just going to leave it as this for now, but just know that we're basically redefining name. Okay, so aquatic.init self, we have to pass in self, and now we should see all three running. And it's better actually to be more explicit if we wanted both. In my opinion, at least, it would be better to say ambulatory.init and then aquatic.init, because if you're using both, if you're using the keyword super with multiple inheritance, it can be ambiguous as to what you're referring to. So my personal preference is to be explicit like this, and we need to remember to pass in self if we're not using super, and then we still get the same 3 init prints. Okay, so that's all that we'll deal with multiple inheritance for now. I just want you to see that it is a thing, but you could probably already see from this super simple example, just one property, right, or one attribute, and just a couple of methods, that there's confusion about where things come from, and what method belongs to what class, and what order things are happening in, and we'll expand on that in the next video. But that's kind of the reason that multiple inheritance is not that often seen. It's a bit controversial. A lot of the times, like on Stack Overflow, people will, post some code that uses multiple inheritance, and a lot of the comments will focus on, you should really refactor this. You don't need to use multiple inheritance. You're just overcomplicating things. And that's true. There's no time you have to use object-oriented programming in general. It's just a tool to help you organize and keep things structured. There's no time where you absolutely have to use multiple inheritance. Anyway, I just wanted to introduce it to you so you know that it's possible in Python. You may encounter it, maybe. I wouldn't count on it. But in the next video, this example and multiple inheritance will help us understand the order that methods are resolved in. So that's coming up next.